Alright guys, this is the part 2 of our solubility lecture. So if you haven't watched part 1, you need to go back to watch it before you watch part 2. Okay, objectives. We will be able to predict whether a precipitate will form when two solutions are mixed given appropriate KSP volume. Now, this is the question. You will have this type of questions on AP type problems. Will a precipitate form? Will a precipitate form? To answer that question, we have to compare KSP to QSP. Yesterday, last class, we said KSP is the solubility product constant. Okay, that's meaning it is at equilibrium where we have a saturated solution. QSP, remember from chapter 15, Q is reaction quotient or the law of mass action. It is the same thing except it is at any other time except for equilibrium. So before I even answer these questions comparing K to Q, why don't we just dive in and solve one problem and see how we can use it. Now I need for you to listen carefully and then make sure you have your calculator ready to do the math with me. Will a precipitate form? Here's the question. 50 ml of, we have 50 ml of 0.0025 molar sodium phosphate is mixed with 50 ml of 0.0025 molar barium chloride. The question is, will a precipitate form? Show all your calculations to support your answer. So you cannot, even if they don't say show your calculation, when they ask will a precipitate form, you cannot just answer yes or no. You need to do work and then answer the question. This is what we will do. I need for you to pay very close attention because in the solubility parts of this unit, today's lecture is the most difficult to understand. So I need for you to pay very close attention. What do we have? Even though the worst thing I can do is draw. Okay, I'm not good at all at drawing. So this is our beaker. Alright, and we have two solutions in it. We have sodium phosphate. If you know your solubility rules, you need to know that sodium phosphate is soluble. All salts of group 1 are soluble. So when you put it in that beaker, you do not really have sodium phosphate, but you have sodium ion and phosphate ion. PO4 3 minus is mixed with. When they say mixed with, you have to be extremely careful. I'm going to show you in a second. Is mixed with. The other solution we have is barium chloride. Solubility rules, barium chloride is soluble. So we will have Ba2 plus and we will have Cl minus. That's what we have in that beaker, those ions. But if we write an equation to find our net ionic equations, we have sodium phosphate Na3PO4, okay, plus barium chloride, okay, aqueous, both of them yield. We have, this is a double displacement reaction. We have sodium chloride, which is soluble, plus we have barium phosphate, barium group 2 plus, phosphate 3 minus. Therefore, barium phosphate is Ba3, PO4 2. Now, this is soluble, this is soluble, this is soluble. So we need to write our net ionic equation. Let's balance first. What is a balance equation? To save time, we have 3 sodium here, 2 sodium phosphate. Okay, 2 sodium phosphate. That means we need 6 sodium chloride. Is that right? So your net ionic equation is really, we need what? 3 barium chloride. 3 barium chloride. Now it is balanced. Now we do not care about all the solubles one. What we really have here is 2 phosphate ion. Okay, let's see. We have 2 phosphate ion plus 3 barium ion yield 2. How many barium? 1. It is just 1 barium phosphate. Okay, so we don't care about anything else. This is our net ionic equation. So in that beaker, what we really have, we have a precipitate of barium phosphate. We learned that it is insoluble, but in this unit, now that you are older, we are telling you it is not insoluble, it is slightly soluble. So whenever you form a precipitate, whenever you have a slightly soluble salt, now we are going to write an equilibrium with that insoluble salt. Okay, let me clear everything. I'm going to clear. Let's just write out. Now, this is our precipitate. We said it is Ba3PO4 2. Always take your insoluble salt, start with it. This is your solid, and write your equilibrium with it will give you Ba3, is that 3Ba 2 plus 2 phosphate PO4 3 minus. This is your slightly soluble salt. This is your equilibrium for that slightly soluble salt, and that's what you use to do your rice table. We said yesterday this is a solid, we don't care. Now we need the concentration of barium and the concentration. The initial is 0, but now our X, the concentration of barium. Now, if you remember a few minutes ago, I told you whenever it says mixed, you have to be extremely careful. Because if you started with a concentration of 0.0025 mole phosphate, I can call it phosphate. Now it's no longer that concentration because I'm mixing 2 different things. I'm diluting that phosphate. I have to divide by the total value. I have to find a number of moles of that compound and then divide by the total volume. I'm diluting it because I'm adding 2 things in that beaker. I no longer have 50 ml, but I have 100 ml with that same number of moles of each ion. So the concentration really of my phosphate is, we can cut it in half because we have double the volume. So what is half of 0.00025 molar? 1.25 times 10 to the negative 4th. Okay, thank you. What is the concentration of your phosphate? No, it's not phosphate. I put it in the wrong place. This is phosphate. Okay. This is 1.25 times 10 to the negative 4. Is that right? The one you just told me. It is negative 4. Now we need to cut the barium into half also. 1.25 times 10 to the negative 3. Okay, so this is the concentration of each one of them. Now we need to find Q. Okay, QSP. QSP, remember I said you need to write the expression first. The expression is the concentration of barium ion to the third power times the concentration of phosphate PO4 3 minus to the second power, and then plug the numbers. So we have, therefore, QSP equal the concentration of barium is 1.25 times 10 to the negative 3, and that concentration of barium, I need to raise it to the third power, times the concentration of phosphate, which is 1.25 times 10 to the negative 4, and that concentration of phosphate, I need to raise it to the second power. So what is QSP? Okay, say that again. 3.05 times 10 to the negative 17. Negative 17. Okay, 3.05 times 10 to the negative 17. Are you sure it's not negative 18? Okay, alright. So I should not follow. Alright, to the negative 17. Now, this is what we do. I need for you. Remember I told you an easy way to compare Q to K. To me, the easiest way is to do the number line. This is a number line. Alright? This is K. We said last time that's where you want to be. You want to be at K. Now, what is K? I add this for you this morning so you won't have to look for it at the end, at the back of your book. I put it this morning. K is 6.0 times 10 to the negative 39. Q is 3.05 times 10 to the negative 17. Q is greater than K. So I put Q right here. Remember, we want to be at K. We want to be at K. So, and if I do look at the reaction here, you want to be at K, therefore, will a precipitate form? The answer is yes, because this is your precipitate. You are going toward the solid. The answer is yes, a precipitate will form, but make sure you always show your work. Alright? Reset. Let's see if we need to do the second one, if it's exactly the same thing we want. Sodium chloride is added to a 50 ml beaker that contains a mixture of this lead nitrate and that amount of silver nitrate. What precipitate? Oh, whoa. This is the hard one. This is the hard one. It is different than the first one. Let me read. Sodium chloride is added to a 50 ml beaker that contains a mixture of, we are not diluting, that beaker already have that mixture, we are not diluting, 0.00015 molar lead nitrate and 0.00035 molar silver nitrate. What precipitate will form first? Show all work, and they give you the KSP for those two. Okay, I add them for you this morning from the back of your book. Let me tell you before I start this, if you check the back of your book or you Google a KSP, there is a chance they will be a little bit different, because like I said in the last lecture, those KSP are determined by experiment. You have scientists spending hours and hours to determine those very, very small numbers. Alright? So, if you Google you will find different numbers. Okay, that's okay. If you are doing quest or you are doing my test, I will have to give you a specific number. So don't panic, don't get upset if you see different numbers. They are experimental values. Now, I need your full attention for this problem. Your very full attention. This is one of the hardest problems for this section. Let me try to make space. Let me try to, let's see, okay. Alright, let me try to understand what's going on. So we have, let me draw my beaker again. Even if it's ugly, I will still draw it. Here's the beaker here. Let's see what I have in that beaker. I have a mixture of lead nitrate, lead 2 nitrate. I learned my solubility rules from chapter 4 in the textbook and know that all nitrates are soluble. All nitrates are soluble. So what I have in that beaker is Pb2 plus and nitrate ion. I don't care about the nitrate ion, it is a spectator. Okay? I'm not going to put it in there, so we won't have too many things to deal with. Okay? The nitrate is a spectator. The other solution we have is silver nitrate. Okay, I know all nitrate are soluble, so I will have silver ion and nitrate ion. So I write down my silver ion. I know silver is 1 plus. I have some nitrates here in the beaker, but I don't care. Now, this is the question. They ask you sodium chloride, that's mean NaCl, is added to. Now you already have that beaker with two of those ions here and the nitrate, and you are adding sodium chloride, but I do not care about the sodium. Sodium chloride is soluble. I don't care about the sodium, it will be a spectator, but I know from my solubility rules that lead chloride is slightly soluble and silver chloride is slightly soluble. So I'm going to put the chloride here. That's what I'm adding. The question is, they ask you, they know you will form 2 precipitate, they ask you which one will form first. And this is a very, very good method of separating ions in a mixture. Like in let's say you have lead in your water, you know lead is toxic, you want to separate it from other ions you have in the water, you add something that will precipitate with that lead first and then leave the other ion in that solution that you need for your body. Okay, let's say you have a solution that has fluoride ion and other toxic anion, you add a cation that will precipitate the other toxic first and leave the fluoride in that water for you because you need it for your teeth. Alright, so this is very practical. Now what do? I could take the time and write 2 full total ionic equations like I did for the other one, but since I already told you that lead chloride will be insoluble and silver chloride will be insoluble, those will be the 2 precipitates that can be formed. What I'm going to do, and I'd advise you to do on your paper, why don't we separate your paper into 2 halves and write down those 2 precipitates that can be formed. Let's write an equation for each one of them. Let me take that chloride to make space. Take this off. This is my chloride ion. That's what I'm adding. So the precipitate that will be formed would be lead chloride, Pb, Cl2. This is my solid. Equilibrium give me Pb 2 plus 2Cl minus. Okay, and then the other precipitate that can be formed is what? Silver chloride, AgCl Okay, we have AgCl. This is a solid, a precipitate, equilibrium, silver ion, and chloride ion. Okay, so now they ask you which one will precipitate first. As you can see, we have a common ion. We have the chloride ion in both of them. Okay, so let's write down the concentration of each one. What is the concentration of our lead? Lead is 0.0000015 molar. The concentration of our silver is 0.00035. I am going to write the expression for each one of them. I'm going to write Q equal QSP equal, write down the expression, it is PB 2 plus time CL minus squared. The expression here, QSP equal concentration of silver ion times concentration of Cl minus. Now, I know KSP, so I can write K here, doesn't really matter. KSP for PbCl2 is 1.6 times 10 to the negative 5 equal, I know the concentration of Pb, which is 0.00015. I need the concentration of chloride. Okay, so times Cl minus. So I need for you to find the concentration of chloride right here for me. Cl minus squared. So it will be the square root of 1.6 times 10 to the negative 5 over 0.00015. If one student can do that for me, I would appreciate it. So chloride for the PbCl2 equal 327 molar. Let's do the exact same thing. The KSP for the silver chloride is 1.6 times 10 to the negative 10 equal the concentration of my silver, which is 0.0035 times my chloride ion. So therefore, chloride ion equal, what is the chloride ion? 0.0457 molar. So I need for you to think. Let's think. Yes, I said think. Can you believe it? I asked you to think. This is chloride. I heard someone doesn't agree with some answers. We can use KSP. KSP. No, I just solved for the concentration of chloride in each one of them. Yes, you can replace those Q by K. It is K. They gave them to me. It was given. I just solved for chloride in each one of them. So chloride is 0.327 in one of them, chloride 0.0457 for the other one. And if I to imagine, I'm adding my chloride. When I add a concentration of 0.0457, my silver chloride will precipitate. We start precipitating. When I add 0.327 molar of chloride, that's when the lead will start precipitating. So which one will precipitate first? The silver chloride will precipitate first. The one that needs the smaller amount will precipitate first. Alright, I see some students, they are looking like very strange. That means one of the answers is not right. Yeah, I think you are right. Well, let me. Yes, you are right. You are right. Okay, point one. Even for this one, I have something different also. Is this one the same? You have the center for that one. For this one, what is it? 4.57. You are right. You are right. So let's correct this right now. It's much, much, much easier to make a correction before I close the video than to do it afterward. So the chloride is 4.57 times 10 to the negative 7 mole. So this is way smaller. That means the silver chloride will precipitate first. All right, the time is up. So if I only solved two problems, even though I said this is the hardest, you still have one more hard, one more hard one, and then it will be. I promise you, after this one, nothing will be harder in chapter 17. Okay, I did not send the unit, but I just said for just that solubility part. Okay, so this will be the hardest. So thank you very much for your kind attention, but the time is up. I have to stop here, and I will have no choice to make a part 3 next class. So enjoy your time. Make sure you do your work. Bye.